So let's look at a special situation. It's the standard normal distribution of standardized values, and we call that z-scores, or Z. So what you'll notice is that right here is the notation. The standard normal distribution that is centered at 0 with a standard deviation of 1, which also means that the variance is 1. And we use z equals x, that's some value, minus the mean divided by the standard deviation. So we are going to do this example here on another screen. So let's take a look at some examples and work through them together. Just as a reminder, the notation for the standard normal distribution looks like this, where this 0 is our mean, 1 is our standard deviation. The z-score, or just z, is some value minus the mean divided by the standard deviation. And then the z-score is simply how many standard deviations from the mean. So let's get started solving these. A z-score is measured in units of the standard deviation. For example, if the mean of a normal distribution is 5, so the mean is 5, the standard deviation is 2, the value 11, so that's x, is 11, and the value 11 is 3 standard deviations above, which means to the right, which means it's going to be positive, of the mean. So we're not solving anything here, we're just setting it up. So you can set it up this way, and all we're doing is showing that in fact all of this is equal. And we can do that. 11 minus 5 is 6. 6 divided by 2. So 3 equals 3. That works. Also, just so you know, if you're ever, we can need to solve and find an x value, we can manipulate this equation, and it would be x equals mu plus z times mu, the mean, plus z times the standard deviation. So you can do that as well. Number 2, what is the z-score of x when x equals 1 and it gives us the standard normal distribution where the mean is 12 and the standard deviation is 3. So let's go ahead and calculate this. Mean is 12, standard deviation is 3, our x value is 1. We are trying to find the z-score. So all we're doing here is plugging this in, our info in. 1 minus 12 divided by 3 gives us negative 11 on the top here, divided by 3, which gives us approximately negative 3.67. So what does this negative 3.67 mean? Well, this means that when x equals 1, the z-score is 3.67 standard deviations to the left of the mean. All right, number 3. Some doctors believe that a person can lose 5 pounds on average in a month by reducing his or her fat intake and by exercising consistently. Suppose weight loss has a normal distribution. Let x equal the amount of weight lost in pounds by a person in a month. use a standard deviation of 2 pounds, and they've given us our distribution here, right, where 5 is the mean, so an average of 5 pounds, and the standard deviation is 2 pounds. It says fill in the blanks. So suppose a person has lost 10 pounds in a month. It is giving us a z-score of 2.5, and it wants us to verify. So just like we did up here, we are just going to verify that that is in fact correct. So we are going to first write out all the information that we've been given, and it's telling us that z is 2.5. So let's just make sure that is actually correct by setting this up. X was 10 minus 5 divided by 2. 5 divided by 2 is 2.5. Yes, that's correct. So this z-score tells us that when x equals 10, 2.5 is the standard deviations to the right, because it's positive, right of the mean 5. So remember, the mean is an average of 5 pounds lost. This person lost 10 pounds in a month, which is more than the average of 5 pounds. B, suppose a person gained 3 pounds, so they've told us here it's a negative weight loss. So that would be x equals negative 3. They want us to find out what that z is. So we already know the mu is 5, standard deviation is 2. Set this up and just plug it in. Negative 3 minus 5 is negative 8. Our answer is negative 4. So what this means, the z-score tells you that when x equals negative 3, when someone gains 3 pounds, it's 4 standard deviations to the left. Notice that I dropped the negative sign because I'm now explaining that when x equals negative 3, when someone gains 3 pounds, it's 4 standard deviations to the left of the mean. So let's say we have some distribution. Looks like this, and I don't know where the standard deviations are, but let's just say that it's over here somewhere to the left. C, suppose the random variables x and y have the following normal distributions. So they've given us 2 distributions here. It says if x equals 17, then z equals 2. This was previously shown. If y equals 4, what is z? So watch out, because they've given us way more information that we need in this one. The only thing they're asking us to find is if y equals 4, what is z? So the only thing we need for this is here, this y equals 4 piece. All right, so if we go based off of this, we've got our mean of 2, standard deviation of 1, our y value of 4, which is the same as like the x up here. We would just replace that with a y, and we are trying to find z. So in this case, it'll be z equals y minus the mean divided by the standard deviation. So the answer here is the z-score is 2 standard deviations to the right of the mean.